Years back, someone told me that they were using PLA for PETG and PETG for PLA supports on their dual extrusion 3D printer with really impressive results. At the time, I hadn't really heard of anyone else doing this, and I've always been curious to see how well it actually works. Although modern slicers have gotten really good at supports, they can still be a pain to remove and leave part surfaces looking less than great. Well, a couple of weeks ago, Snapmaker sent over their J1 IDEX 3D printer that has all metal hot ends, and I knew the time had finally come to test this out. In today's video, we are going to do some experimenting and see how well this does or does not work. So with all that being said, and without further ado, let's get right into today's video. Aside from being able to print parts that are multicolor or multi-material, one of the biggest pluses of a multi-extrusion setup is the ability to use a different material for support material. The most common are water-soluble like PVA and BVOH, or a breakaway material. We covered PVA last year, and although it has its use cases, needing to dissolve supports after each print can be time-consuming and messy. Breakaway, on the other hand, works very similarly to how traditional supports are used. When the print is done, it is meant to break away, hopefully with minimal effort compared to using the same material for both your primary part and the supports. From personal experience, breakaway materials definitely do work, but they're often at least twice as expensive as some of the more common filaments. This is why the idea of being able to use PLA for PETG supports and PETG for PLA supports is so appealing. If it works well, you likely already have that filament laying around, and it's going to cost you much less. For the testing, I found a fairly simple support test model over printables that I felt would be perfect. It has curved sides and a large unsupported area, which would be tough to print without having either the supports sticking to it or having sagging lines underneath. All the test printing was done using Prusa Slicer 2.6 Alpha 5. As far as settings go, I printed both the PLA and PETG at fairly standard temperatures and speeds with a 0.2 layer height. It's been some years since I've had that conversation about PLA and PETG for supports, but from what I remember being told, you do not need to have any gap between the top of the supports and the bottom of your part. This is highly uncommon, and Prusa Slicer has this name soluble because generally speaking, you would need water-soluble supports if you planned on ever getting them removed. I wanted to see how well this worked, so I did go with zero gap, and I printed a 200% scaled up version of the support test using PLA with PETG supports and PETG with PLA supports. For fun, I also printed PLA with PLA supports and PETG with PETG supports at no gap and 0.1 gap. After all the parts finished printing, I started off with trying to remove the supports from the PLA with PLA support models, and I had no luck. The 0mm gap version was bonded together, and the 0.1 gap print I also had no luck with. For reference, in Prusa Slicer, Super Slicer, and Orca Slicer, the default gap between supports and your material is 0.2, so even at 0.1, we're talking 50% closer than you would typically print those if you're using default settings. As for the PETG with PETG supports, I had a little more luck. I was able to get both of the support blocks removed with the help of some tools, but they both looked pretty bad. If I spent a bit more time, I'm sure I could have gotten the 0.1 gap PETG cleaned up a bit more, but I still don't think it would have been very pretty. So for the moment of truth, I grabbed the first of the PLA and PETG prints, gripped the supports, and with a slight twist, it popped right off in one piece, leaving zero residue on the bottom of the part. I then grabbed the other part, printed with the opposite materials, and the exact same thing. It popped off with little effort and no residue from it on the bottom. The bottom of both of these parts look near identical, and I am blown away with how clean they are. The pattern on the bottom of them is from the interface layer, and making the interface layer solid would remove that. Years ago, I would dread printing models that required a lot of supports, and there is absolutely no way that I thought I would be able to print models like this using PLA with PETG to get results that looked this good. This definitely isn't something I'm going to be using all the time, and of course it does require a dual extrusion or a multi-tool head 3D printer, but knowing that this is possible and these are the results that you can get is really exciting and can come in very handy for specific parts. Let me know in the comments down below what your thoughts are, and if you have any specific materials that maybe you would like to see combined in a future video. I definitely think it'd be interesting in exploring this a bit further and seeing how certain other materials behave with each other. One that I am specifically interested in is TPU, because a TPU print with TPU supports pretty much always welds to each other. On that note, don't forget to like and subscribe for more great videos. We make a video every single week, so there's always fresh content coming your way. And if you do want to support the channel furthermore, I'll have links down below in the description over to our Patreon where there are some really awesome rewards. Huge thank you to all of our existing Patreon supporters. I appreciate each and every one of you for allowing me to come back every single week and spend more time doing what I love, which is making content for you all to enjoy. On that note, this has been Daniel from ModBot. I look forward to seeing you guys in my next video. Peace, guys!